Hello everyone, I'm Priyadarshini Sendil Kumar, Technical Marketing Engineer from the Switching TME team. In today's session, we'll talk about auto-enable RPVST during VLAN creation as a part of the 10.13 update. Here is the usual agenda for the section. Let's quickly jump into what the feature actually is. So the overview of the feature. So spanning tree protocols are used to prevent loops from occurring when multiple paths exist between switches. They're used to provide redundancy, and this avoids the loop structure and also the proliferation and infinite cycling of packets that would occur in a loop network. In a narrow sense, enhanced spanning tree protocols derived from STP is RPVST and MSTP. In Aruba switches, the default mode is MSTP. In RPVST, each VLAN would have its own route and own calculations and send out their own BPDU. In this sample topology, with and without RPVST, in the second topology, we can see that RPVST runs different spanning trees for different VLANs, and in this case, it creates a spanning tree for VLAN 10 and VLAN 20. So the existing capability that comes with RPVST is that a user can create an RPVST instance manually along with configuring specific parameters like priority, hello timer, etc. From the 10.13, we have a single CLI command that helps enable or disable RPVST auto globally on VLANs that are existing as well as newly created. This avoids the need for specifying RPVST on each VLAN instance manually. So here is an example of configurations prior to 10.13 and after 10.13. Let's look at the use cases of this feature. RPVST allows for load balancing across multiple paths of different VLANs. This means that traffic can be load balanced across the paths, improving network efficiency. When a loop topology occurs, or when a topology change occurs, only the affected VLANs need to recompute. This minimizes the impact of network changes and reduces the risk of downtime, making network management less complex and less prone to service disruptions. It also helps to scale up in multi-vendor environments where sometimes the user might forget to enable RPVST on thousands and thousands of VLANs that are existing in a particular switch. It helps in such cases as well. So as a part of this feature, we'll concentrate on the building 2 with two aggregates 8325s and the 4100s connected to each other in a triangular fashion. So let's move on to the details. So auto VLAN enable command enables RPVST for all VLAN specified under the capacity field of each switch. So the show capacities RPVST command gives you the information on the number of VLANs and the vPorts in the switch and how much can be configurable. So the show capacity status RPVST gives us the VLANs and vPorts that are currently configured. In this case, let's say a user creates more than 32 or 512 VLANs or vPorts in case of a 4100i switch. Then RPVST is applied until only the scale limit, which is 32 for VLANs and 512 for vPorts, and not beyond that. So let's look at the configuration of this feature. So auto enablement of RPVST can be done in two methods, either by specifying the VLAN list or without specifying the VLAN list. So here the CLI that we are using is spanning tree mode RPVST auto VLAN enable. So I have VLANs 1 to 1000. So spanning tree will only run on VLANs 1 to 32 maximum supported as in 4100i. Similarly, I'm issuing this command on the global context without specifying the VLAN list. So it is again the same case with this as well. So disabling auto VLAN enable. For example, let's say we have VLANs 1 to 1000 and we are telling spanning tree VLAN 25 to 30 should be disabled. So in this case, what happens? Spanning tree VLAN mode RPVST auto VLAN enable runs on VLANs 1 to 24 and again from 33 to 40. And this is not sequential, and the VLANs that are need to be disabled, that is 25 to 32, will not run RPVST auto instance. Configuring the global STP timer values, let's consider the priority value here. So the auto VLAN command feature, the auto VLAN feature supports only changing the priority timer value and not any other parameters. So other parameters like forward delay, hello time, max age or max stop, we have to get into the legacy mode and change them. So here, for example, from VLAN 1 to 1000, I'm telling that the span tree mode RPVST auto VLAN enable priority is 2. So this priority 2 is uniformly applied to all VLANs that are created and newly created and existing. So here is a screenshot of the web UI of the switch and how RPVST auto can be enabled or disabled from the web UI context. So here, once you're able to edit the spanning tree mode, you will see a prompt where it allows you to enable or disable the RPVST auto on the switch. You can also configure the priority here. Default priority is 8, so I have configured 2 just to show it as an example. So let's move on to the best practices. So it is always recommended to not allow more VLANs or VPorts to be used than the maximum capacity that the switch actually shows. Only select the VLANs required on a specific link for the allowed list based on the requirement on each port. For example, let's consider we have VLANs 10, 11, 12 and 15. It is not recommended to use VLAN trunk below all. Rather, we can use VLAN trunk 10 to 12 and then 15 as well. So as highlighted earlier, VLANs can still be created after the mentioned capacities, but RPVST is not applied above the scale limit, which is something important to note and as all a best practice to follow. So let's look at the demo. So as a part of the demo, we'll consider 3 switches, the 8325 aggregates A and B, and my 4100i, which I have connected here. So here are 2 interfaces, and we'll be trying to create VLANs and check if RPVST is applied to them or not. So I've already created a couple of VLANs in 8325s just to save some time. Then into the 8325A, 8325B, and my 4100i switch. So let me show the VLANs here that I've already created, VLANs 5 and 6. So we have VLANs 5 and 6 already created. Similarly in this as well. And let me go ahead and create VLANs 5 and 6 in 4100i2. So now let's see the existing spanning tree mode in the switch. So the default mode is MSTP, so I have not configured RPVST yet. So I'm showing this with respect to the 4100i. So let's try to enable the CLI here. So once I enable this command, let's see the output for show spanning tree. You will see that the enable protocol here is RPVST auto now. And since I created 2 VLANs 5 and 6, you can see that the root ID and bridge ID are assigned for them as well. And my VLANs 5 and 6 are assigned to interfaces 1/1/27 and 28. Here my VLANs 5 and 6 are interfaces 1/1/2, as well as in my first switch the VLANs are assigned to 1/1/2. So now so here I've already enabled RPVST. Let's check our VLANs. It's better to check it this way. So you can see that the interface 1/1/2 in VLAN 5 and 6 are designated and forwarding ports. Same is the case here as well. The priority is 32/760, which is a default priority. The second switch, VLAN 5 and 6 are designated and forwarding. Similarly, 6 as well. Let's go to the 4100i, which I assume will be the root switch now. Yes, so 27 and 28 in VLAN 5 and 6 One is the root port, another one is the forwarding port, and in 28, one is alternate, another one is in blocking state. So by which we can confirm that RPVST is applied perfectly and it's up and running. So now let's try to configure the priority command. So the default priority is 8. I'm trying to configure 2. So let's see the show spanning tree display for this. Now you can see that the priority has changed. So priorities are multiples of 44,096. So that is pretty much it with respect to the demo. Thank you for watching the session.